In this video, we're going to look at how we use the intermediate value theorem in our homework. And as you can see up there, it says existence of a solution. So this is the example from my notes, and it says, does negative x to the fifth minus 4x squared plus 2 square root of x plus 5 equals 0 have a solution on the interval from 0 to 3? Okay, now notice it doesn't say solve it. It just asks, does it have a solution on this interval? Okay. So the first step for these homework problems is you're going to name f of x all the stuff to the left of 0. So negative x to the fifth minus 4x squared plus 2 square root x plus 5. Okay, so that's our function. Okay, now, second thing, the most important thing about the intermediate value theorem, we need to know if this is continuous. Okay, so let's look at what we know about continuity. And by the way, continuous on, let's be more specific, 0 to 3. Now you're probably wondering, Jen, why did you put brackets? Because in the theorem, it has brackets when we are talking about where it's continuous, okay? And then this parentheses is saying that the solution is in between those values. Okay, all right. So polynomials are continuous everywhere. So this guy, and this guy are continuous on here. The square root of x is continuous on 0 to infinity. So we are good. I'm saying that this is going to be continuous. It's not going to break on this interval. So yep, it passes. Okay, again, how did I know that? Because of our first video about continuity, talking about polynomials and square roots where they are continuous. So this guy is good. It passes. Okay, now, here's the next part. We're going to plug in 0 into this function. So if you plug in 0 into this function, you're going to get the number 5. Then I'm going to plug in the number 3. And where I'm getting these numbers of 0 and 3 are 0 and 3. Okay, so if I plug in 3 into this equation, and I've already done this with a calculator, we're going to round and call it negative 270.5. Okay, now remember my car example? If I'm continuous and going from 0 to 60, I have to hit every number between 0 and 60. If I'm continuous, I have to hit every number between 5 and negative 270.5. So, what we want to know is, did I pass 0? Did I have to cross 0? If I'm continuous from a y value of 5 to a y value of negative 270.5, did I pass 0? Yes, I had to. If I have one positive, one negative, I had to pass 0. Now, if I had positive and positive, or negative and negative, then my answer would be no. Okay, so what this is telling me is that passing 0 is the same thing as saying that this whole thing, at some point in here, this function is going to equal 0. That's the same thing as solving this equation. So when it says, does this function, or does this equation equaling 0 have a solution on this interval? What we've shown by the IVT is that yes. Let me write it over here. Yes, by the intermediate value theorem, because the function is continuous, and because of this fact, at some point on 0 to 3, it will equal 0. So yes, a solution exists. We didn't find it. I didn't say, oh, by the way, it's 1.75. Nope. All I know is it exists. Somewhere between x is 0 and x is 3, it's going to cross the x-axis. We're just saying that a solution exists on the interval 0 to 3. All right. These are the last couple problems in your homework. Try and model it this way. If you get a positive and positive, you say no. Nope, sorry. At this point, we can't say a solution exists. If I get negative and negative, again, I don't pass 0, so we'd say no, we can't say at this point a solution exists. It could, but we can't guarantee it. The only way we can guarantee a solution will exist if I get a positive and a negative. And by the way, it could be reversed. The first number could be negative and the second could be positive. I just need to have one of each. Good luck.